Hello everyone, welcome back to StudyBuddy Code channel. We're solving SAT maths questions in the domain algebra. The difficulty level is medium. These questions that have been selected are not in any BlueBook practice test. If you would like to know how I've selected these questions, you can go back to the first video in this playlist. Let's read the question now. At how many points do the graphs of the equations y equals x plus 20 and y equals 8x intersect in the xy plane? So I'm going to let you pause the video and try to solve it by yourself first. Okay, so here we've been given two linear equations. A linear equation, the general form of it is y equals mx plus b. And here, these two are linear equations because x doesn't have any power to it. For example, x squared, that's quadratic, or x cubic, then that's a cubic function. Here it's x to the power of 1, so it's a linear function, okay, or equation, sorry. Okay, here our first equation, it's x plus 20. Here b is the y-intercept, okay, so the y-intercept in this one is 20, and the slope is m. Here, the slope is not 0. It's not there, it's just x here. However, it's 1 because anything times 1 would be the same number that you're multiplying 1 with. So 1x would be x plus 20. So generally, it's written like this. However, the slope, there is a slope, and the slope is 1. Here, the second equation, 8x. Here, we do have the slope, which is 8. And yes, we do have the y-intercept. Just because there's nothing adding to this 8x doesn't mean that we don't have a y-intercept. We do. It's plus 0. 0 is the y-intercept. I mean, you wouldn't write something that's adding with 0 as that, right? You would just write it as 8x. That's more simpler. So we do have a y-intercept here, and it's 0. Okay? Now, to solve this question, it's actually really nice to solve it with Desmos. So you can get a quick answer and you can just move on by, like choose your option and just move on in the exam. However, I'm going to explain because there's a certain rule that you must know. Okay. This rule, okay, applies to only two linear equations. Please make sure of that, okay? Only two linear equations. So, the intersections, the type of intersections for two linear equations are only three types, okay? The first one is zero intersections, which means there are no intersections. The second one is only one intersection, or you can have infinite intersections. I'm going to explain these three in a bit now. So when I say this, when you remember this rule that two lines can only have these three types of intersections, and if you look back to the options here, you can immediately strike off option C and D because the only three types of intersections that can happen are 0, 1, or infinitely intersecting. Since here we have 2 and 8, you can immediately strike them off, okay? Got it. Now, I'm going to explain each case now. You have 0 intersections, okay? When you have two same slopes. So what do I mean when I say two same slopes? If you have already studied these before, you must know that when you have two equations with same slopes, 5x plus 2, that's 5. X plus 2. These two equations are parallel lines because they have the same slope. And if you have the same slope but different y-intercepts, then they are parallel. All right? Okay. So in that case, you have 0 intersections because two parallel lines never meet, correct? Yes. Okay. That's one example. The second case, when you have one intersection. That is bound to happen when you have two lines. I mean, two lines can only have one intersection or zero intersection or infinite intersections, correct? So that happens when you have different slopes and different y-intercepts. Okay, so different slopes. Oh, I forgot to write something here, which is y-intercept. Now, when do you have infinite intersections? That's when you have the same equation. I'm not going to say same slopes and same y-intercept. I'm going to directly write it as same equation. Okay, same equations, okay? For example, 5x plus 2 and 5x plus 2. These two equations are the same, and they would have the same slope, same graph, same everything, of course, same graph. So that's one. And if I choose another color here, then I can show you. And let's imagine the other line is exactly on top of it, okay? Then these two equations are the same, so they have the infinite intersections because they're literally intersecting at every point here, correct? Yes. Okay. You could also, because it's not usually 5x plus 2, you're not usually given, oh, you have these two equations, find the intersection and you have the same equations. No, it's a little bit trickier. You could get it as, okay, the first equation might be 5x plus 2, and the second equation might be, hold on, y equals, because there's a catch here. Okay. And here, for example, 3y equals 15x plus 6. So did you see what I did there? I multiplied 3 to everything here. So 3 times y, which is 3y. 3 times 5, which is 15. Oops. 3 times y, which is 15, and 3 times 2, which is 6. If you type these two equations in a graphing calculator, or Desmos, that is, you would get the same exact graph. And that's when you have infinite intersections, okay? Let's solve the question now. We're going more into theory here and the rule. Okay. Here, so these two equations, they have different slopes. Immediately, you can say it's one intersection because, so that means one intersection, all right? Now I'm going to show you how to solve this using Desmos. Okay, so I've typed the equations that they gave us in the question here. And, okay, this is what you would get if you're zoomed in here, and if you zoom out a bit here, you would find only one intersection. Okay, now that's it. We've solved the question. You can check it with Desmos again, and you can move on in the exam. However, I want to show you the examples when you have zero intersection first. So 5x plus 4 and 5x plus 2. Here we have the same slope, but not the same y-intercept. So they have zero intersections because they're parallel lines, and parallel lines never meet. Now let me show you the example of infinite intersections. Okay, let's see, y equals, what was their example? Okay, let me type a new one, 6x plus 2. And another one, which is 3y equals 18x plus 6. Now, if you zoom out, you would only find one graph, no matter how much you zoom out. And no matter how much you zoom in, you would only find one graph or one line here. That is because if I turn this off, there you go, you have the other graph. This means that they are on top of each other. If you would like to check once more, you could, let me show you. How do we do that? Okay, go to settings here and then click on here. and choose a dotted line or this kind of line. I like this one better. You can see that it's exactly on top of each other, because if you divide this by 3, let me hold on. Okay, yeah, if you divide this by 3, you would get this equation. So that means they have the same equation here. So that means they are infinitely intersecting each other. All right.